In this video, we're going to look at factoring something called a perfect square trinomial. So in order to understand what a perfect square trinomial looks like, I think a good place to start would be to go back to multiplying, because remember, factoring is undoing multiplication. So let's say we had something like 2x plus 3 squared. All right? So to do that, we would need to write 2x plus 3 times 2x plus 3. Remember, to multiply this out, you're going to use FOIL. So we're going to go 2x times 2x, which is 4x squared. 2x times 3, which is 6x. 3 times 2x, which is 6x. And 3 times 3, which is 9. All right, so that gives us 4x squared plus 12x plus 9. Now this trinomial is called a perfect square trinomial, and here is why. Because if you factor this trinomial, you would end up with 2x plus 3 quantity squared. So the two factors are exactly the same, so you can write it as a binomial squared. So this guy right here is called a perfect square trinomial, sometimes abbreviated PST for perfect square trinomial. Now let's look at the pattern. We want to be able to recognize these perfect square trinomials so we can more easily factor them. So first of all, let's look at our checklist. We have the fact that it's a trinomial. There's 3 terms. 1, 2, 3. 3 terms, okay? Check. Second thing, the first term and the last term are perfect squares. So here we've got the first term, which is 2x times 2x, 2x squared. That's would give me 4. The quantity 2x squared would give me 4x squared. The last term is 9, which is 3 squared. That gives me 9. So the first term and the last term are perfect squares. Now the middle term, I said, is 2ab. Let me show you what I mean by that. Let's say we had just a trinomial a plus b times a plus b, okay? Or excuse me, a binomial times a binomial. So if I multiply that out, I get a squared plus ab plus ab plus b squared, which is a squared plus 2ab, there's the 2ab I'm talking about, plus b squared. So when I say the middle term is 2ab, the a refers to whatever is needed in order to square and get the first term. So in our example down here, the a value is 2x. The b is whatever you would need to square to end up with the last term. So in our example, b is 3. Let me write that, how about right here? In our example, the a is 2x and the b is 3. The middle term needs to be 2 times a times b. All right, so a times b in our case is 2x times 3, which is 6x. So 2 times a times b would be 12x, which is exactly what we have right there. All right, I know that's a little tricky, but the idea is the first term is a perfect square. All right, so you figure out what does it take to square, that's your a value, to get your first term. The last term has to be a perfect square. So you could think of it as like taking the square root of that. The square root of 9 is 3. And then if you multiply those two things together, the 2x and the 3, and double it, you get the middle term. Then you know you have a perfect square trinomial. All right? Let's look at one other one that we could do. Let's say we've got, how about 9x squared plus 24x plus 16. Is that a perfect square trinomial? Well, it's a trinomial, certainly. Okay, that's good. The first term and the last term are perfect squares. Yes, they are. This first term is 3x squared, and the last term is 4 squared. Is the middle term 2 times a times b? So remember, the a value is the 3x. The b value is the 4. So is the middle term 2 times 3x times 4. 2 times 3 is 6, times 4 is 24. We have it. Okay, so that's a perfect square trinomial. Now, once you recognize something's a perfect square trinomial, factoring it is super easy. Okay, let's erase this part here. The factoring comes straight from what I have written right here. This a plus b times a plus b multiplies to be a squared plus 2ab plus b squared. So this is the factored version of the perfect square trinomial. It's just a plus b times a plus b. So if we come down here to factor this, we've already determined it's a perfect square trinomial. So this is going to be 3x and 3x to multiply to be 9x squared. And then what times itself is 16? That's 4 and 4. And then all these are positive, so we make it both positives. That's it. That's all there is to factoring it. It has to be a perfect square trinomial, though, to fit this form of factoring. Now we could check this, and that always helps by foiling it out. So 3x times 3x is 9x squared. 3x times 4 is 12x. 4 times 3x is 12x. 4 times 4 is 16. We combine like terms with our x terms, and we end up with what we started with, so we know our factoring is correct. Now typically when you see this kind of a problem, the final answer will be written as a perfect square, like 3x plus 4 quantity squared, like that. But if you wrote it out with two binomials, it would be correct. Now I'm going to add one little caveat to this checklist over here. Our middle term could actually be positive 2ab or negative 2ab. Let's see what would happen if we made this middle term right here negative 2ab. What would we have to change in our factoring so that when we FOILed it out, we ended up with a negative 24 in the middle? Think you can see it? Well, hopefully you see it. You would just make this negative 4, or minus 4, minus 4. That's still going to give you a positive 16. But when you FOIL it out, you'd have negative 12x, and negative 24x. Alright, I paused the video there for a second to make some room for one more example. Let's say we had 4x squared minus 20xy plus 25y squared. Alright, I want you to just pause the video for a second and go through the checklist and see if you think this is a perfect square trinomial. Alright, so we know it's a trinomial. That's good. 3 terms. Is the first term a perfect square? Yes, it's 2x times 2x. Is the last term a perfect square? Yes, it's 5y times 5y. Is the middle term positive or negative 2ab? Alright, so let's think about what the a and b values are again. The a value is 2x because it's what you multiply together to get 4x squared. So we have 2x. Let me just jot that down here. That's okay. Let's put it in red. So that's a value is 2x. The b value is what you would multiply by itself to give 25y. That would be 5y. And I want to know, is the middle term 2 times a times b? So we have 4 times 5 is 20, xy. That's it. All right, and it's negative, so that's fine. So we know this is a perfect square trinomial. All right, if you haven't done it already, I suggest you pause the video and see if you can factor this. Okay, so to factor this, all I have to do is basically make it look like this, a plus b or a minus b. So my a value is 2x. That's going to go here and here. My b value is 5y. And since I need a negative in the middle, I'm going to go negative, negative. And I can just write that as 2x minus 5y squared. That's it. Perfect square trinomial. All right. Now, always be aware with any kind of factoring, there could be a greatest common factor in there that you have to get rid of first. For example, if I started this problem that we just did, let's say there was a factor of 6 in there or something. So I could easily just put a factor of 6 in there. Is my pen gonna work? Nope. Let's try it one more time. There we go. Let's say I had 24x squared minus 120xy plus 150y squared. Oh my gosh, if I saw that for factoring, I would think those numbers are big and they have a lot of factors and this is going to be tough. But the key is to recognizing that 24, 120, and 150 probably have a number, a common factor, a number that goes into all those numbers. And it's 6 in this case. And I have some other videos on greatest common factor if you want to look at those. But if I take that 6 out, take out the greatest common factor, 120 divided by 6, 150 divided by 6. Now I end up with this trinomial that's a lot more manageable, actually, right? It's the one we just did right there. So you could finish it off. Always look for that greatest common factor. Sometimes that can, if it has one, it will always make the trinomial easier to factor. So in this case, the final answer would be the same as the other one, with the exception of you'd have a factor of 6 multiplied in the front. All right, well, I hope that helps.